is the effect of the neural machine translation on translators and the translation process. Andy Way is a professor of computing at Dublin City University and deputy director of the 100 million euros Adapt Center for Digital Content Technology. He has over 350 peer-reviewed papers, most of which are on machine translation. He was president of the EAMT from 2009 to 2015 and the president of the IAMT from 2011 to 2013. He has been editor of the Machine Translation Journal from 2007. He received as well the IAMT Award of Honor in 2019. Thank you. And now, Dr. Way, feel free to start.
Okay, thank you very much. Yeah, let's hope the technical issues are zero during this talk. I heard Masaru say that during his talk that he was nervous. The only thing that I'm nervous about is that the technology holds up, so fingers crossed. So yeah, thanks to Michael and his colleagues for inviting me. I'm very pleased to be here virtually. I haven't, well, this is actually the second keynote talk that I've given in a week in my office, and I haven't done that before. So away we go, with fingers crossed, as I say. Okay, yeah, I wasn't sure whether I was going to record the talk like Maeve did, so I put a picture of me in action, if you like, on this slide. But essentially, I'm going to talk about, the fact that, MT is in use today, billions of words by millions of users. So I'll start the talk off with that sort of premise, accepted perhaps by everybody in the talk. One nice thing about being last at a conference is that you can try and draw together some of the themes from other people's talks. But, the disadvantage is that some people have said some of the things that you wanted to say. So, many of the talks have featured the increase in hype with the onset of neural machine translation, and not just in MT, but also in AI in general. When I was talking to Michael about what sort of thing I could talk about, he thought it might be a good idea if I show you briefly how neural machine translation works. So I'll show you a very simple model of how NMT works, if you and hope that that might be interesting for some of you. And then, of course, we've had this crop up in talks, Masaru's talk, Maeve's talk. Should translators be afraid of NMT? Is NMT sounding the death knell for human translators? And I've given lots of talks in my sort of career, and recently I've tried to give more talks to human translators rather than at scientific conferences. So this is one in a series of similar talks that I've given elsewhere. And to give you the punchline, I hope that you should not necessarily be afraid of neural MT. That's the punchline. So it will be an awful shame if the alternative were true. And then to address the aim of the conference, I'll try and tease out a few themes. This is obviously crystal ball gazing to some extent, to talk about the impact on translators and the translation process. So this is my starting point. I've had discussions before with human translators who say that machine translation is useless and irrelevant and is never going to be of any use. And I don't accept that anymore. I mean, I can accept that a translator would say to me that it's actually no use in my particular use case, and I would accept that all day long. But in the era of big data, you have big numbers to back up some of your claims. So every year Google has an on-site conference where it sort of bestows the virtues of all of its online services. And this is from 2016, where they were talking about the throughput for Google Translate, and the numbers are astonishing. This is 143 billion words translated per day. That's today, yesterday, tomorrow, the day after, every single day. This is one provider, albeit perhaps the biggest provider of machine translation on the planet. So I have no truck with anybody who says that machine translation is useless. It is not perfect by any stretch of the imagination, but you cannot have these volumes, and this is one provider, you cannot have these volumes on a daily basis if millions of people are not finding machine translation to be useful for a range of use cases. So let's start from that premise. But as we've seen, particularly in Antonio's talk there, a couple of talks ago, there has been some hype associated with neural machine translation, and it really started in 2016 with this paper published by Google, and the words I want to bring your attention to in the title are bridging the gap between human and machine translation. So they didn't, mention human parity here, but they did say that they were getting sort of closer and closer. And of course, when we see these things, this is not the first time that translators have seen this sort of thing. And so the hype gathers pace. And you see things like, the journalists publishing things like it's nearly indistinguishable from human translation, pretty much as good as a human translator. It's a miracle. It's approaching human level accuracy, translates as well as humans can. It's a major breakthrough. It's close to manual translation. And this is what we see all of the time when a paper like this comes out, especially from a group like Google Translate. And what do translators think? Well, you've seen this before. These are real live websites that you can point to. Is Neural MT really as good as human translation? Can it compete with human translation? Will it replace us? Will interpreters and translators' jobs die out, etc., etc., etc.? So this is translators and interpreters do fear for their for the future of their careers when they see these sorts of headlines. And it's up to people like myself and Antonio and others to dig a little bit deeper and see whether these claims hold water. So here's another one. Maria's question to Antonio reminded us that this paper is about news. This is from Microsoft, achieving human parity, and this was the one that created even more attention from journalists. Because of the words human parity. Chris went from Microsoft, when we started to challenge this, in discussions, initially on Twitter, and then Antonio and myself and others, we tried to actually dig a little bit deeper, because Microsoft, very gratefully made their data and assessments available to anybody to play around with, which was great. But Chris went, who runs the team, his reaction to the initial criticism was that they're not claiming human parity. They're claiming human parity in a very sort of tightly controlled environment, only for Chinese to English and only for news. And Maria pointed that out earlier on in her question to Antonio. But the only thing that most people, translators perhaps, but certainly journalists latch onto are the words human parity. Now, the first author here, Hani Hassan, was a PhD student of mine, and Hani, I know, from working with him, over a 4-year period, he's a very humble man. He would not have chosen that title himself. So my, gut feeling on this is that it's Microsoft's PR people trying to compete with Google's and go a step further, not trying to bridge the gap here, but actually achieve human parity. So again, what sorts of reaction did we see in the press? Historic milestone, AI matching human performance, achieving human parity, huge breakthrough, it's as good as humans, achieving a milestone in machine translation, human parity achieved, so not in that specific, use case for that specific language pair, but human parity achieved, okay? And again, here's another one from SDL. This was in 2018, also in 2018. You can see the title of this. This is a PR piece on SDL's website. SDL cracks Russian to English neural machine translation. So if you know, I'm a native speaker of English, obviously, and I know what cracks means. Cracks means you've solved the problem, like you've cracked a code and you can understand the enemy's secret messages. So cracks here means solve the problem. Now, firstly, Russian to English is a hard language pair, and obviously, neural machine translation is not perfect today, and it certainly wasn't perfect in 2018. So, our challenge, from the group with Antonio and Shayla and Kay, who challenged Microsoft's claim of human parity and showed it not to hold water, was to SDL to make their data available, and we would do another similar evaluation, and I'm sure that we would demonstrate that it really hadn't cracked Russian to English neural machine translation. Kurti Vashi, who I challenged at the time online, said, well, yeah, but we didn't really mean crack as in solve. And of course, we had papers earlier on by Natasha, for example, where they were talking about translation ambiguity. But for me, as a native speaker, cracks is not ambiguous here. And Antonio, talked about possible superhuman performance at 2019, which his latest work, presented today, shows not to be the case. But similar claim continued into this year. He showed this article as well in his talk. But again, achieve, what does it say? Reaching news translation quality comparable to human professionals. And again, this is in one of the Nature series, so this is going to be an important paper. So these sorts of things, we better get used to these sorts of claims, because they're not going away. As you can see, from 2016 through to almost the current time, this was only the 1st of September 2020. These claims are fairly commonplace nowadays. So in my career, 30 years now, essentially all I've been trying to do is to show what MT can do, and equally to show what MT cannot do, and try to sort of placate human translators who in the face of these sorts of claims start to fear for their careers and something that they've trained many years to specialize as expert human translators. And machine translation, especially neural machine translation, is quite hard to understand. And especially the journalists themselves, they just take these claims at face value and publish them. It's difficult for non-experts to actually dig beneath the surface and examine these claims. So I know there's a major announcement on Monday from another MT provider, and again, a couple of journalists have reached out to me, and I've tried to offer my opinions on that. You'll have to wait until Monday, because I'm under an embargo. I can't say any more than that. I'll probably be up before a judge if I say anything more than that. But the point is, machine translation has been overhyped for years. This is from a slide that from Philip Kuhn, from Johns Hopkins, who also works for Omniscient with Dion Wiggins, and you can see that there's obviously a schematic of the historical situation with respect to machine translation. So starting back in the 50s with a very limited experiment where they could translate 50 words in a bunch of sentences, with rule-based MT, and then expert systems came in and people thought, okay, this is gonna lead to some sort of breakthrough, and then SMT came in for sort of 25, 30 years, and things did improve. And now neural machine translation has come in the age of AI, and as soon as you mention AI, people start to get overexcited and think that all of a sudden that these machines are going to replace us, and that's simply not the case. So the reality is obviously much below that, and it's, like I say, my intention today to try and point out what MT can actually achieve nowadays. And again, Antonio mentioned this paper from 2016 at EMNL by some authors in initially all in FBK in Trento. A really nice paper on how to do human assessment of translation quality, of MT quality. And what they did there was, from the 2015 IWSLT, one of the shared tasks that people like me and Antonio would compete in, what they examined was a neural machine translation system of Luong and Manning against 3, if you like, state-of-the-art different flavors of phrase-based SMT. And not just, so they looked at the quality itself, the quality of the MT output from each of the 4 systems, but also in terms of post-editing. How easy was it to post-edit SMT versus NMT? So this is not an easy task. English to German, reasonably hard language pair, and this is what they found essentially was, I'm going to go through this quite quickly, but using TER that has been mentioned in a few talks, which is a proxy for the amount of edits that a human might have to make to turn NMT output into a good translation, an acceptable translation. So essentially, so TER is an error metric. So the lower the score, the better. So you can see at the top, the kind of orange and yellow graphic shows that the NMT score had a better, the NMT system had a better overall quality than any of the three SMT systems. The left middle one, the green one there, in terms of looking at lemmas, it had fewer lexical errors, so it was better at lexical selection. The pink one on the middle right showed, so shifts are, if you like, cut paste edits. So it had better word order. There was less requirement for cutting and pasting more than one word. And the bottom one shows that when you compare words against lemmas, then it had fewer morphological errors. So really, this was a breakthrough that NMT at this point started to show its mettle and start to demonstrate better performance, certainly in terms of these automatic metrics than different flavors of SMT. And we know, of course, that NMT is extremely data hungry. So a paper by Kern and Knowles, 2017, showed they compared NMT against a phrase-based model and a phrase-based model with a large language model. Antonio again talked about language modeling earlier on. And they trained English Spanish from 400k words to up to almost 400 million words. And you can see, for the green graph is the NMT system, and it starts off really badly. So with the data, these are blue scores, and it's only getting a blue score of 1.6, with the 400k words. But it starts to increase quite rapidly and crosses the blue line, which was the vanilla, if you like, phrase-based model, at around 10 million words, and then continues on to beat the larger phrase-based model with the large language model with about 2 billion words. So it does improve, but it starts off with quite poor performance with what are reasonable amounts of data for SMT training. But there's been a recent paper by Rico Senric and Biao Zhang, 2019, which revisits low-resource neural MT and shows that, in fact, you can get quite good MT quality with much with NMT with much lower amounts of data than was previously thought. So that paper is worth checking out. So as I say, NMT is reasonably hard to understand. But beneath the, and you hear all these sorts of terms about, deep learning and neural networks and stuff, but actually the underlying methodology is reasonably simple to capture. So essentially, you have some input. Okay, so for us in translation, so our input would be our source words, and our output will be our target words, or words and phrases, if you like. And then we have one or more hidden layers, and this can be quite complex. You can have many hidden layers, and you can see that all of the nodes in one layer are connected to all of the nodes in the next layer. So that's important. So essentially, what we're going to do is proceed from left to right through this network and try and produce a translation. Okay, so the input is encoded. Before I say that, so each of the arcs between the nodes in one layer and the nodes in the next layer have weights on them. And initially, these can be just random numbers. And we'll, as we continue through training cycles, these weights will be refined to produce the best performance for this particular NMT model. So initially, the words in our source sentence are turned into a mathematical vector, just a list of numbers, numerical representation. Our hidden layer will consist of a vector of hidden nodes, and our output layer are words, or what the NMT system outputs will be a vector of output nodes. And of course, then we need to translate that into those numbers into actual target words. So as well as those three vectors, you have a matrix of weights which connect the input nodes and the hidden nodes, and another matrix of weights connecting the hidden nodes and the output nodes. And of course, if you had two hidden layers, you'd have another matrix of weights connecting hidden nodes in one layer with hidden nodes in another layer. So but essentially the only two mathematical constructs that you need to worry about here are vectors and matrices. So we can add vectors together or subtract them, and we can multiply matrices together, and that's essentially the only operations which are going on here. So if you think back to your high school maths, all of us would have looked at sort of matrices and vectors at that point. So it's not any more complex than that, although the number of calculations which are performed even in a relatively small system are billions of calculations. So what do we do essentially? So we're going to, what we always do when we build a system, we're going to have some training examples and then some held out test cases. So to exemplify how this neural network works, well, I'm going to focus on providing on image. So given a particular image, the system will have to predict a label. So and there are only 4 labels here: cats, owls, dogs, and lions. And you can see then, once the system has been trained to work as best as it can, we will confront the system, the frozen system, with those test examples, and we'll just see how it gets on. So essentially, we have a large amount of training data, and and this is sort of pre-annotated. So these will be sentences for us, and we will push those sentences through the neural network and obtain a translation at the back end. And then we might compare that translation to the reference translation in terms of a BLEU score or some sort of human analysis on some sort of Likert scale. And then if it's low, we will push that error back through the system, and re-tweak the weights, and then we will push, we will retrain. We'll push the same example back through the network until we get the right example. So here, in terms of our image recognition, if I have a picture of a dog, and the output is cat, then clearly that's an error. I need to percolate that error back through the network, come up with some different numbers on the arcs, play with the weights, and then try that one again until we get the label that we expect, which will be dog, of course. And we can do this until the output doesn't get any better. Or, for example, we can say, well, we'll do this for 50 training iterations, for example. These are called epochs. Depending on how much time you have available. A customer can't keep a customer waiting forever in the expectation that the translation performance will continue to improve. So at some point you might just have to say these are the best translations we can get in the time available. So essentially we just learn by trial and error. So we have a picture of a dog which will be turned into input vector, maybe in terms of black and grey and white elements and shape and shapes, for example. So our poor little dog there is turned into a set of numbers, and we just push that through the network, and we then see what the label is. So the label should be dog, but the system actually outputs cat. So clearly that's wrong. So we have to go back through the system. We have to update the weights and retrain. And then after many training examples, hopefully, we will push that representation of our picture of a dog through, and the output from the system will be the same as the label. So now we've got this right. There's no need for us to reconfigure the network because we've actually made the right prediction here. So essentially, then we keep doing that. This is obviously a very quick synopsis of how this works. So we trained the model to work as best it can. We then freeze that system, and then we confront it with our test data. So if you remember, we had a cat. So let's push that through the network, and it has label cat, and the system actually predicts that yes, this is a cat. So whoopee, we got that one right. We take our picture of an owl. Again, our representation of the owl is pushed through, and the system gets that one right as well. And then we have a dog, and again, the system is able to correctly predict dog. And then we have our picture of a little lion cub. And of course, this is hard for the system to get right, because if you remember, the training examples for lions were all big daddy lions with big manes. And this little lion cub looks a bit more like a little kitten than a lion. So unsurprisingly, the system gets this one wrong, and we get 75% accuracy. And that we can report as the efficiency of our system. So back to translation then, neural machine translation, just like phrase-based SMT, okay, is using machine learning, and typically now deep learning. And deep learning, all deep learning means is that you have more than one hidden layer. So, if we're going from source language to target language, we have a machine learning algorithm, whatever the flavor of the month is, and we apply that, and we observe the outputs from our NMT system. So the big difference between phrase-based SMT and NMT essentially was that in SMT, all we ever did was we translated words and phrases, and then we stuck the translations of those words and phrases together at the back end, and we hoped that we had a reasonable translation at the back end, but we never had a model of the whole input string. Whereas in NMT we do. So I think this is the biggest reason why NMT works better than phrase-based SMT, is that we're actually translating with full sentential context. And of course, we've had talks at the conference, showing how important context is, and unsurprisingly, and this is given that you have a full sentential model of the source string, that you can translate better than you could with phrase-based SMT. And this is not exactly the state-of-the-art model nowadays, but it's essentially one of the best models, recently been surpassed by the transformer architecture. But for a long time, the state-of-the-art was this encoder-decoder with attention NMT model, where you essentially have 3 neural nets, all working together. You have an encoder neural net, which encodes the source language, a target neural net decoder, which produces the output words, and then you have this attention model. And again, Natasha earlier on gave the well-worn bank ambiguity example, and the attention model essentially looks for other words in the sentence which are important to take into account when you're trying to translate a particular word. So with the bank example, if you were able to look ahead and find a word like river or a word like money, then that would satisfactorily disambiguate that source word and help you select the correct target translation. But these networks are huge. Here's one just for recognizing handwritten single numbers. Yeah, so there are only 10 possible inputs, 0 to 9, and look how big this particular network is. Presupposing that you have images of handwritten numbers, perhaps 28 by 28 grayscale images of those numbers. So obviously, handwriting recognition of 10 particular digits is a much easier problem to solve than than the machine translation. And it's fair to say that new use cases are emerging all the time. So there are many use cases which are not trying to compete face to face, if you like, with human translators. We came up with one there in 2014 where we translated 83 million words of tweets which had the World Cup 2014 soccer hashtag in Twitter. So again, I did some sums after the event, and if we had human translators to do this, then it would cost us over 3 million euros. So in that sort of context, where all you want to find out is your fellow fans from a different country, what are they thinking about the match that you're watching from a different perspective. then that translation was good enough. And here's a nice new use case that I saw the other day. You can see quite a new one. Arlington man arrested after trying to rob a bank using Google Translate. So I hypothesize that it's difficult to see a human translator agreeing to this job. So here was hopefully a satisfied user, although he didn't get away with the money. He was locked up, as you would expect, for being this silly. But in any case, should translators then be afraid of neural machine translation? Well, the nice thing is that this underlying architecture of neural networks underpins a wide range of different tasks, like speech recognition or caption labeling or image recognition. So let's look at how it gets on in some of those other areas. We'll also look at how it gets on with translation. But here's an example I've used before. So some of you may have seen this picture, and I apologize if you've seen it before. But you can see the punchline essentially. What you're going to do here is confront the NMT system with labradoodles and fried chicken and ask it to see if it can distinguish between the two. Now, again, if I asked any human to do this, we would all get 100% and pass our degree with flying colors. But computers find this quite a hard task. Here's another one. And I think this is a bit harder than the previous one. I might struggle to get 100% on this one, but essentially, the punchline is, you're trying to get the system to distinguish between chihuahuas and muffins. And I have to say that some of these pictures of muffins, if that's a muffin in the top left corner, for example, it looks astonishingly like a chihuahua. So this is quite a hard task. It seems to me a harder task. I wouldn't guarantee that I get 100% on this task. Here's another one, caption labeling. This is a real example. The boy is holding a baseball bat. Well, I don't know whether that's a boy or a girl. Looks to me a bit more like a girl if I had to put money on this. But I know that he's certainly not, or he or she is not holding a baseball bat. So clearly that is an error. But as I say, the same sort of underlying architecture is going on here, which is being used in NMT. So here's an example from neural machine translation itself. And some of you may have seen this one. It was from Google Translate, the 18th of July, 2017. And we talked about, spurious examples that the MT system might output. And if you type this sentence in now, Google Translate doesn't produce the same output as you see there on the right. So, I'm not going to go through the German on the left-hand side, but let's just look at the right-hand side. The economics of economics, brackets, including economics brackets, is a part of economics. So the first thing to notice is, of course, that is an English sentence, although one which is fairly nonsensical. It's a well-formed English string, which a language mod, for example, that Antonio was talking about, would accept as a piece of English. But of course, it makes no sense whatsoever. And as a translation, it's absolutely useless. And what's happened here is, I talked briefly about the attention model and it focusing in on, the most important words in the sentence to try to drive the production of the correct targeting. So what it's found here is in the German side that words which kind of mean economics are important, and it's thought them to be overly important and overly produce those on the target side. So this is obviously a terrible translation. So in Alan's talk, again, talked about the problem of, MT fluency really is more or less gone away because, NMT really is producing quite fluent outputs now. But what about adequacy? And, Michael asked a question earlier on about, hallucination by NMT systems, producing outputs with nothing to do really with the source input string. And here's an example from EAMT 2018. This is just a photo I took while Nick was giving his talk. And the one I want you to look at is the example which says, so the third one down, ¿por qué no tengo servicio de internet? So So because I don't have, internet service or internet connection. And the NMT system was actually produced, the room was very clean and the staff was very helpful, which of course is an English sentence. And again, you might expect to have internet, connection in a hotel room, and you would expect to have, a clean room and staff come along who are helpful in a hotel context. But the sentence, of course, that is actually hallucinated is nowhere near a translation of the source text. So when we talk about, how the machine translation, or how the translation process is affected by NMT, there have been LSPs who've been trying to save money by using monolingual post editors, believe it or not. And I think this sounds the death knell for those LSPs and that particular application. And we've seen today, Antonio pointing out reference bias among monolingual annotators. You really, if you don't look at the source sentence, then, you might easily just accept this as a good translation when it's absolutely a terrible translation. And again, Masaru, in his talk, he pointed out that correcting NMT errors requires near professional translator competence. And here's a nice example, I hope, illustrating why. And a bit like, May's analogy earlier there, with Excel, people need to learn how to use machine translation properly. So just like it was in the COVID situation that May described, sometimes MT is, if you like, unfairly blamed for things when it really wasn't MT's fault. It was just, people failed to use it in the way that it should have been used. So here's an example here, where somebody did not sort of pre-process the input text to show that the machine translation system that it should not translate literally the words of the Osaka metro stations. And of course it did this, and then things got translated in a hopeless way, in exactly the same way that you wouldn't want my surname to be translated into all sorts of weird and wonderful target language words. So just pre-processing the station names with do not translate tags would have solved this problem. So this is not an MT error. This was one I saw recently. This was on Twitter. None of the translations are very good, but the one that people wanted to focus in on was Trockenwohnung. So the English was obviously dry, flat. Yeah. So if you have a cashmere jumper, you don't want to hang this up, on the washing line because it might just start to sag and lose its shape. So there are some clothes where the instruction is to dry your article flat on a clothes horse or whatever, and it's translated flat here as apartment, Wohnung. Okay, so this is just clearly somebody using machine translation with no knowledge of the source text or source language or the target language. And again, we're increasingly seeing these sorts of things. And here's a nice one in Ireland of a sign where it says footpath ends in 40 meters. They got the 40 meters right. They wouldn't get a non-zero blue score here. But Asquelga just means in Irish. So they're waiting. The project manager here, whoever was in charge of this particular translation job, really messed up because they thought that Asquelga meant footpath ends in, where it just means like insert the Irish translation here. So we need knowledgeable project managers in the translation pipeline, and examples like this might show that you need arguably bilingual ones too. And Maeve talked about the return on investment that people had actually seen versus what they had been promised by MT providers. And my experience is so I went to work for two machine translation companies there from 2011 to 2014 in the UK, and I don't think either company really understood how disruptive introducing machine translation into the translation pipeline actually is. So it's not just disruptive for the MT team, but it's disruptive for every single person in that translation pipeline: project managers, translators, people who have to do the pricing, the software team, and the hardware team, making sure that you have adequate machines on which to train your in-house examples, etc., etc. So, I think that's a point that's come through a number of talks. So even with NMT, machine translation is still hard. I've been doing machine translation for 30 years. It's a hard problem, an interesting problem, and still not a solved problem, despite what some people would say in the literature and also in newspapers and online websites and blogs. So there's still lots of remaining problems. Just because you've changed to a different paradigm doesn't mean that all of the old problems that we know from rule-based MT and doing contrastive linguistics, they haven't been solved by neural machine translation yet. And of course, the point is that translators are already well disposed towards technology. This is Jos Zetcher, who you will all know, Jeromabot on Twitter. Back in 2017, I seized this quote because I thought it was a very useful one. The public thinks that technology takes care of translation, but good technology is all about making good translators better. And I think that hits the nail on the head quite well. But interestingly, even in 2020, there's some resistance. So on 14th of October, what was that? Tuesday, Wednesday, I think it was. I attended an online conference there, put together by the e-translation team in the DGT, and they did a poll. Here's the answer to this question: do you use or plan to use any automated translation system? For example, e-translation or any other machine translation system. So a lot of people said, yeah, I currently use one. Yeah, I plan to use one. But 6%, so 7 out of the 115 people voting, were absolutely adamant, okay, that they would never ever use machine translation system. They hadn't used one up to this point, and they didn't plan to use one in the future. Now I can't be sure that all 7 people voting there were human translators, but some of them, quite possibly could have been. So there is some resistance still from some people, and that's fine if they've tried it out, but and found it not to be useful for their particular, use case. But clearly, these people, were sort of so dogmatic, almost, it's almost a religious thing for them that they said that they would never ever use MT. So to the point of the conference, then, so what about the impact on translators and the translation process? Well, obviously, I'm putting my finger in the air here a little bit, because improvements in NMT are hard to predict. But we'll have to see. I think translators will, in the future, post-edit fewer machine translation outputs. So human translators are quite used to having no help when translating a particular source segment. You might be a human translator who sets the fuzzy match score quite high. And of course, this is always a trade-off between precision and recall. So you might just want to get, like good suggestions from the translation memory system, and and then when you don't get any suggestion, you just translate, from scratch, as you've been, trained to do so over many years. So I think one thing that that we should have anticipated as MT developers. But I think it was wrong for the softer underbelly, if you like, of our systems to be exposed to translators. Just because MT can always translate something, it doesn't mean it's always going to translate something very well. So we have shown human translators not just the good translations that our systems can produce, but also the really, really bad ones, the hopeless ones. So those translators then are not filled with a huge amount of confidence, because MT can make really stupid mistakes that no human would ever make. So I expect as quality estimation improves, that the MT systems become better at predicting, how good a translation they've actually managed to produce is. And if it's so bad, I think it's better not to show that to a post editor, and they can use a fuzzy match. Or if they don't even get a fuzzy match or any MT suggestion, then they can just translate from scratch, and I think that's fine. There'll be an increasing demand for spoken language translation. I think that's true. So my kids, or 3 teenagers, never type a query into Google like I do. They think, that's archaic. They just shout at Siri, looking for an answer there. And it's a fact that about 20% of Google search queries are now through voice. So we certainly need to deal with the particulars of speech, the false starts, the fact that most sentences that we actually speak are not bona fide sentences of our language. But again, our language processing systems are very robust to those errors. By and large, we don't even notice them. But I think that's going forward, there'll be more and more data around with instances of spoken language translation for us to try to translate better. Literary translation, I think, will increasingly involve MT. The work that Antonio and I started to do, I said, what's the kind of last bastion for human translators? And we agreed it would be translation of literature. But what we've actually found is that machine translation, and NMT in particular, is actually quite useful. And can produce quite good and useful translations for human translators to consider post-editing. So I think that will continue. And of course, machine translation will improve for hard languages and resource-poor scenarios. But even when it does that, there's a huge long tail of languages for which data really doesn't exist, and new emerging use cases all the time for user-generated content, for example, where there really isn't sufficient parallel data, or in some cases any parallel data for training of our MT systems. Interactivity is improving all the time, as Spence showed in his talk. And incremental retraining, where an MT system can adapt to the translator edits, is sort of tried and trusted technology nowadays. It's quite easy for us to do, and it's great because the human translator sees very quickly that the edits that she is making are useful to her as well as to the MT system. So there we can override the default translations which are being produced by, or suggested by the system, and actually overwrite those with the preferred translations suggested by the human translator. And of course, ultimately, you can't do good MT without input from linguists and translators. Where does the training data come from in the first place? To the top right diagram there on this slide, shows that the parallel data comes from humans in the first place. We've had lots of talk about evaluation, and I had a recent conversation with a reasonably large MT provider who relied 100% on the automatic metrics. And of course, we've seen lots of examples, in this conference and other places where clearly just relying on numbers is not a good idea. Translation is about words and sentences and paragraphs, and just if you just rely on numbers suggested by some sort of machine translation metric, then you're not going to ultimately produce the sorts of MT systems that we want. So all of this area of quality estimation and improving the output from our systems is down to human translators. We showed again in the human parity paper that there was a huge difference in the ratings of unqualified and qualified human translators. And we can all understand why unqualified translators are used, but really then you have to take any results based on unqualified translators with a grain of salt, because they have they're far too accepting of MT errors as good translation utterances, which clearly a human translator who has been trained to a very high standard is much more able to spot. So just to conclude then, neural machine translation results are really promising. It's a significant improvement in performance. I think this might be an opportunity for human translators. I've suggested this before, as perhaps LSPs are a bit slower to update their rate cards if they don't understand the technology. NMT is clearly better than SMT was, so maybe they're still using the same rate cards because it's MT post editing rather than NMT versus SMT post editing. When data is scarce, SMT can still work quite well, but pretty much the whole field now is working on NMT. So new ideas are coming out all the time, and breakthroughs are being made not just in MT but in parallel fields in different use cases, different application areas where we can bring in insights from there into machine translation as well. And of course, we know the whole industry is eager, for improved machine translation quality in order to drive down costs. And it's probably a takeaway from Maeve's talk that's probably gone too far now. But my final point really is that we need to be careful about overhyping NMT. Just distinguish the hype from the reality, because overselling a technology, even if it's a massive improvement over the previous state of the art, will cause negativity, because people's expectations will be far too high. So Guru Mila Mahagat. And to be cheeky, I'll put this slide up, if I may. So any questions?
Oh, thank you so much. This was really impressive. Dear participants, now feel free to ask any question by clicking on, by raising your hand, or just like you can type your questions. Yes, Maria, go ahead, please.
Hello, Andy. Thank you for your
Hello.
presentation. Yes, one thing I was just thinking, and I've been trying to research myself, is we are comparing, or we are using machine translations to substitute, or well, not to substitute, but to be at the parity of professional translators. But what about, and we are translated into our native language, which is quite high, the bars for an NMT. But what I would like to know is, what about NT translation for those who are trying to translate into foreign language into English with a high level of English as well? Because it seems to me that a lot of MT is being used for all the website content. So social networking, Facebook, all that, in which people might have a high level of English, but yet not enough to, to dare to translate into English. And I think from Spain that many people attempt to do translation, the websites. If you look into Spain, in many companies, they do their own translation. They are not native British or English, and they dare to translate into English. And I can see in all the website that is an Spanish or person with a high level of English, but not enough to translate yet into English. So my question is, the errors that we experience in machine translation, how similar or how are to those errors that a foreigner will do when translated into a foreign language and not having enough knowledge in pragmatic context, someone who has studied English from Spain but never been in Britain or America or any English-speaking country, and has no awareness of so much as the context, like in machine translation. Probably the major error will be context. I don't know if you understand what I'm trying to say.
Well, probably two things to say, and I hope one of them is an answer to your question. I mean, just to focus in again on the human parity. I mean, if you would imagine, or you might reasonably claim, and I might reasonably claim, to my students in a lecture, for example, that if NMT is achieving human parity, well, if it's that, you should measure that particular claim, or the merits of that claim, not just in what NMT gets right, but also what it gets wrong. So if we really are mimicking what humans do, then we should get things right just the way that humans do, but we should make the same sorts of mistakes that humans make. And I don't think that the mistakes that NMT is making at the moment are, or certainly some of the mistakes that NMT makes, no human translator would make those mistakes. So the other thing I was going to mention was, I know that many companies use MT to come up with multilingual versions of their websites. Maybe this was what you were thinking about in your question. And clearly, some of those translations will be incorrect. And what some people would do then, the company would do is, look, the more imprints that they get, the more views of that web page they get, then they might use precious human resources to actually post-edit the MT and make those translations, better than they were. So rather than pay for, expensive, human post-editing from the word go, it will be user-driven, and they will then make that decision after they have seen how often people are accessing that content. So I think it's a kind of a cheap and cheerful way to see what the interest is in your various multilingual versions of the original English web page.
Yeah, what I was trying to say is, for instance, in my case, my native language is Spanish, but after living and working here in the UK for many, many years, my level of English is I guess, is high, but not as high as it will be the Spanish. So if you offer me if I am in a match with a machine translation translated into English, how much that MT will the parity with my translation into English? That's what I will. I know I could go higher into Spanish, but into English, because what I find is MT in Europe, because we all seems to be translating or wanted to translate into English all over the world. Perhaps that could be used as a tool to translate into a foreign language more than in your own native language if you are a professional translator. Don't know whether I explain myself.
Well, I guess yeah. Well, I guess once you've built a system, I mean, it's really open to all sorts of different people at how to use that system. And again, if people use it in ways in which the developers have not really intended, then I guess you can't legislate for that. If people, it's all about training. And again, we have lots of translator training courses, and people like myself and Antonio and Michael would try and talk about how machine translation actually works. I tried to do that a little bit today in order to try to educate people as to how you should and should not use MT. But if people use it, in ways in which they really shouldn't be, I guess certainly you can't blame the MT system developers for that.
Okay, thank you.
Yes, Barbara, go ahead, please.
Good afternoon. Thank you, Andy, for that wonderful speech. I'm a Spanish professor and I teach translation, and so I'm very new to this, and I'm just interested sort of on a conceptual, very abstract level here. But what I've been noticing is that there's a lot more talk about, when you're talking about training and things for translators, there's a lot more talk about localization being introduced rather than translation. And my question to you is, how does that change the dynamic or the task of developing neural machine translation? Is it making its way sort of into being able to also perform localization tasks?
Well, I mean, translation, or whether it's human translation or machine translation, is only one part, albeit a significant part of the entire localization process. Right. So I certainly wouldn't want to claim that. So I'm certainly not claiming that we can do translation properly, let alone other aspects of the localization pipeline. So I would imagine that even some of those outlandish claims that you saw in Antonio's talk and in my early slides, I think some of those people would not say that they're trying to solve other localization problems as well as translation problems.
Okay, thank you.
Well, thank you. We have a question or a comment from Ipro. Go ahead, please.
Yes, thank you very much. An excellent speech. I have a question about context and whether current systems have a way of, also understanding the context in which speeches or these texts are produced. Thank you.
I mean, in many of the talks, if I just go back to Antonio's talk, he talked about the definition of human parity, and in Alon's talk, where he was talking about evaluation, he was giving like definitions, and of course some of these definitions are a bit shaky. What do these things actually mean? What does understanding actually mean? So while my NMT system might produce some good output, to what extent can I really claim that it's understanding, the source text, the target text, and the whole translation process? I certainly wouldn't want to be brave enough to claim that. But what we can do, of course, is we can build MT systems, whether they be SMT systems or NMT systems, for specific domains, and we can do domain adaptation. We can build a model and then tune it with language from a specific domain to try to produce translations which are reflective of, let's say, the terminology that you would see and expect to see in a particular domain. So yes, we can do that, to a greater or lesser extent. And again, most of the time it relies on or depends on the amount of training data that you actually have. So so I just encourage people, I'm abusing my position now, I'd encourage you to come to EAMT. All of the proceedings are already available, 500 pages of MT, where we have a translators track. So, some of you will be especially interested in that. So I encourage you to come, especially to the translators track.
Well, this is a great. Thank you, Professor, for the great presentation. And now we will have a break until 3:30, and we will be back again for the roundtable. Thank you so much.
No problem. Thank you very much, everybody.